All right, hi, I'm Mr. Justice, and this is a supplementary lecture that goes along with 1.8 on primary productivity. Let's begin. The amount of energy available in an ecosystem determines how much life the ecosystem can support. Take a look at the diagram here of the lake, right? This area here, it's not labeled, but this darker area, the profundal zone, is an area that doesn't receive any light or much light at all. And because of that, it won't support plant life. Therefore, it's not very productive. Whenever you hear the word productivity or productive, you should think producers, plants, photosynthesis. Compare this, the profundal zone here to an area that would be able to receive some of that light. It's shallower, right? Because of how deep it is here, light can penetrate through the water and we can support either submerged plants or plants that can live up out of the water. Likewise, this area, the limnetic zone, that area in the top of the lake where algae can accumulate, it gets plenty of light, so it's a productive area too. Take a look. This is the difference between plant and animal cells. We're talking about primary productivity, and so it's important to know a little bit about what's going on here with the plant cells and the animal cells and the differences between them. Lots of differences, but the ones that I want to point out here are the chloroplast, right? Animal cells don't have chloroplasts, whereas plant cells do. These chloroplasts are organelles that are able to capture and convert the light energy from the sun into chemical energy in the form of organic compounds or sugars, glucose specifically. Animal cells don't have chloroplasts, and so their source of energy doesn't come from the sun. It ultimately comes from the sun, but it doesn't directly come from the sun. It comes from the fact that animals are eating either plants or eating animals that ate plants, and that energy is transferred and broken down by the mitochondria, right? If you remember the mighty mitochondria, the powerhouse of the cell, animal cells have one, and the mitochondria is what's breaking down that organic compounds, those sugars, the glucose, using that energy and producing carbon dioxide and water as a byproduct. But here's the reason why I'm having you guys take a look at this slide, is because in addition to chloroplasts, plants also have a mitochondria, right? This is one of those big misconceptions, right? We think plants are making their own food that the animals use. No, the plants are making their own food for themselves. Not only are the plants able to convert that light energy into food, into nutrients, into glucose, it can also break down that glucose and use it for their own metabolism, for their own metabolic processes like growing, replicating cells, dividing, right? Take a look, right? So not only are the plants making their own food, they're using it too. So when we talk about primary productivity, if we were to measure primary productivity in an area, we would have to account for the amount of that food, that biomass of that's represented in the organic compounds, the sugars. We have to subtract that from the total. We measure the total productivity, and then we subtract out the amount used for respiration through the mitochondria. That's what primary productivity is referring to. Take a look. Let's talk a little bit more about these processes, right? So there's the chloroplast. The chloroplast is responsible for photosynthesis, right? Where solar energy along with carbon dioxide and water, along with a chloroplast, will fix that carbon dioxide into organic compounds, and that's that glucose that you're seeing on the screen. And it produces oxygen as a byproduct too. So that in the mitochondria, the glucose, the organic compounds produced during photosynthesis, along with the oxygen needed, is going to respire and break this down to produce carbon dioxide and water as waste products, but most importantly, a lot of usable energy in the form of ATP. It's important to note I've highlighted the C in these equations on either side of this arrow because it highlights the importance of the carbon cycle. This is the carbon cycle, right? The carbon in carbon dioxide in the atmosphere is fixed into organic compounds, glucose. right? We've taken carbon dioxide out of the air and we've brought it into the biosphere. And then within that biosphere, that organic compound sugar can be broken down into usable energy, ATP, but it produces carbon dioxide, returning the carbon dioxide back into the atmosphere out of the biosphere. So here's my question. How can you measure the rate of photosynthesis, aka primary productivity, in an ecosystem if plants are using up some of that productivity for themselves? The answer is you have to calculate total productivity and subtract the mass lost to the producer's own respiration. You've got to look at the total rate of photosynthesis and then understand that those plants are using some of that energy for themselves through their own respiration in their own mitochondria. So we have to account for that subtraction from it. And what's left over would be what's called the net primary productivity. Take a look here. I like this picture here, right? The ultimate source of all energy here on our Earth is the sun, and plants are able to convert that light energy into food, into a different form of chemical energy, glucose, right? So take a look. Let's follow this diagram. Glucose is produced during photosynthesis. This is called gross primary productivity. It's kind of like my paycheck. I have a gross pay rate, right? That's the total amount that I'm paid. Let's take a look. Some glucose used to supply energy to drive cellular processes. So some of the glucose produced during photosynthesis is going to be used by the plant's own respiration. So let's go back to that analogy with the gross paycheck. My gross paycheck is my total paycheck, and then what's taken away from it is the taxes. So you can kind of think as respiration as a tax. So what's left over then, the remaining glucose available, is laid down as new material. That's that biomass, that plant material. What's left over is my net primary productivity. Kind of like my gross paycheck, after we take away the taxes, what's left over is my net pay, right? Well, my net primary productivity is the remaining amount of glucose available to other primary consumers, secondary consumers, the decomposers, the tertiary consumers. We've got an equation here. NPP is equal to GPP, the total amount, minus what's left, used for respiration, R. You can think of NPP as being a measure of an ecosystem's production of plant mass. It's its productivity, right? NPP is the rate of photosynthesis over time. You might wonder about this question. What factors could affect NPP? Well, the factors that could affect NPP are temperature and availability of water, precipitation amounts, right? Take a look at this. Let me go to this website. This is a website on NASA's website. Take a look. We've got a picture of our Earth. This is from February 2000. So these darker green areas represent productivity. So the darker the green, the more productive. And it shouldn't be any surprise that the areas where we find tropical rainforest, even though it is in wintertime, February, it is still pretty productive. That's because the temperature, right, that area, the equator, is getting a full brunt of that sun. It's going to be one of the warmer areas in our world right here, right? Likewise, because it's warm, that water is not frozen. It can be used for cellular processes. So I want you to take a look at the shifting of the green and kind of try to take a look too at the months as we go through. All right, so I'm going to push play. Notice the warmer summer months. We have more productivity in the areas that normally would maybe be the tundra, right? That has that permafrost up there. And then in the winter time, there's less productivity. So, right, think about temperature, think about precipitation levels. Notice that the desert area right here in Las Vegas and Henderson, where we are, is less productive. Well, even though it's really warm, it has going to be impacted by precipitation levels too, right? If you've got plenty of temperature, you're warm year round, but you don't have the water because of the rain or the snow, then you're going to be less productive as a result. So let's go back to this. What I'm going to have you guys do is get into the video lecture from Mr. Smeeds, available on day 9 of our Canvas page. And I want you to continue to take notes. based off of that lecture.